Have you ever wondered how our life-giving sun came into existence? A captivating question indeed, and one that takes us back, way back, to approximately 4.6 billion years ago. At this time, in a quiet corner of the Milky Way galaxy, a giant molecular cloud began to collapse under its own gravity. Picture this, not as a gentle descent, but as a tumultuous contraction. As the cloud shrank, it spun faster and faster, much like a skater pulling in their arms during a spin. This spinning action flattened the cloud into a disk shape. This is what we call a protoplanetary disk, a spinning whirl of gas and dust, teeming with potential. Now, the center of this disk was under immense pressure. All that gas and dust pressing down created intense heat, and in this hot, dense core, something remarkable happened. The hydrogen atoms, which made up the majority of the gas, started to collide. When these collisions reached a certain speed, the atoms didn't just bounce off each other, they fused together. They literally combined to form a new type of atom, helium. This process is known as nuclear fusion, but nuclear fusion is no ordinary chemical reaction. It releases an incredible amount of energy. So much energy that it caused the core of our protoplanetary disk to light up. And that, ladies and gentlemen, was the birth of our sun. The nuclear fusion in its core has kept it burning brightly for billions of years, providing the heat and light that allows life to flourish on our planet. So the sun, our very own star, was born from a cloud of gas and dust, igniting a fiery existence that continues to this day. From a humble beginning, it has grown to be the heart of our solar system, the source of energy that powers our world, and that's just the start of the story. From its fiery birth, the sun embarked on a life cycle that's more fascinating than you might imagine. Right now, our sun is in its prime. It is a main sequence star, the most common type of star in the universe. This means it's in the stage of life where it's burning hydrogen to produce helium in its core. This process is known as nuclear fusion, and it's the source of the sun's energy, the energy that powers life on Earth. Imagine the sun as a massive, self-sustaining nuclear reactor continuously converting hydrogen into helium. Every second, about 600 million tons of hydrogen are converted, with about 4 million tons of matter being transformed into energy. The heat and light produced in the core takes 1,000 years or so to reach the sun's surface, and then just about 8 minutes to travel the 93 million miles to Earth. This phase, the main sequence, is a star's longest life stage. For a star the size of our sun, this stage is expected to last about 10 billion years. In astronomical terms, that's quite a bit of time. To put it into perspective, if the entire history of the universe were condensed into a single year, the sun's main sequence phase would span from about March to December. So where does that put us now? Well, the sun is about 4.5 billion years old. It's middle-aged, having spent about half of its life in this stable phase. But don't start planning the sun's retirement party just yet. It's got about another 5 billion years or so to go, give or take a few hundred million years. During this time, the sun will continue to burn through its hydrogen fuel. As it does, it will grow hotter and brighter. Slowly but surely, the sun's increased brightness will cause the Earth's climate to change, but that's a story for another time. For now, the sun continues its journey through the main sequence phase, providing the energy that powers our world and makes life possible. It's a constant, a fixture in our sky, a symbol of stability and endurance. It's hard to imagine a time when it won't be there, shining down on us. But like all things, the sun too has a lifespan. As we move forward, it's important to remember that our understanding of the sun, like our understanding of the universe, is constantly evolving. What we know today may be expanded or revised as we continue to explore and learn more about the cosmos. But for now, this is where we stand. Our sun is middle-aged, having spent about half of its life in this stable phase, with another 5 billion years or so to go. And while we have a good idea of what's in store for our sun, the exact details are still a mystery we continue to unravel. So, what happens when our sun exhausts its hydrogen fuel? This is where our celestial journey takes a turn towards the dramatic, the grand finale of our sun's life, so to speak. The sun, like all stars, is on a cosmic clock, ticking down the seconds until it burns through all of its hydrogen fuel. When that happens, the core of the sun will begin to contract under the force of its own gravity. As the core contracts, it heats up, getting hotter and hotter. This heat causes the outer layers of the sun to expand. Our sun, once a bright yellow ball in the sky, will swell into a red giant. Now you might be wondering, why red? It's because as the sun expands, its surface temperature actually decreases, giving it a reddish hue. So, our sun, once a warm yellow beacon of life, will transform into a cool red behemoth. And as a red giant, it will be enormous, engulfing the orbits of the inner planets, possibly even Earth's. But that's not the end of the story. The sun's core will continue to contract until it becomes so hot that it begins to fuse helium into heavier elements like carbon and oxygen. This will cause the outer layers of the sun to be violently thrown off into space, creating a beautiful gaseous envelope around the sun, a planetary nebula. In the heart of this nebula, the remains of the sun's core will be left behind. This core remnant, no longer capable of nuclear fusion, will be what we call a white dwarf. Despite its name, a white dwarf is incredibly hot when it's first formed, shining with a fierce white light. But without any source of energy, it will slowly cool over billions of years. As it cools, the white dwarf will fade, its light dimming until it's barely visible. Eventually, the once brilliant star will darken completely, becoming a black dwarf. This is the ultimate fate of our sun, a dense, dark, cosmic ember. But don't panic just yet, these events are still quite a ways off. In fact, it's estimated that our sun won't exhaust its hydrogen fuel for another 5 billion years. That's longer than the Earth has existed. And even after it becomes a red giant, it will take another billion years or so for it to shed its outer layers and become a white dwarf. So, while the death of the sun may sound ominous, it's a natural part of the life cycle of stars. It's a process that's been happening throughout the universe for billions of years. And when it does happen, it won't be a sudden explosion but a slow, gradual transformation over billions of years. In about 5 billion years, our sun will bid its fiery farewell, leaving behind a cosmic remnant, a white dwarf. A silent testament to the once vibrant star that nurtured life on our little blue planet. This brings us to a pressing question. What does the sun's life cycle mean for Earth? The sun's life cycle, as fascinating as it is, holds profound implications for our home planet, Earth. One could say the sun and Earth are locked in an intimate cosmic dance, with each phase of the sun's life cycle leaving its mark on our planet. As our sun ages, it will eventually swell into a red giant, a phase that will see it growing larger and brighter. In its monstrous red giant phase, our sun's outer layers will extend so far that they will likely swallow up the inner planets, Earth included. A scenario that sounds like it's straight out of a science fiction novel, doesn't it? But it's a scientifically plausible future, based on our current understanding of stellar evolution. However, before you start panicking about the Earth being gobbled up by an oversized sun, it's worth noting that life on our planet will have ceased to exist long before this cataclysmic event. The culprit? The sun's increasing luminosity. As the sun burns through its fuel, it gradually becomes brighter. This increase in brightness or luminosity will cause a steady rise in Earth's temperatures. Over a span of 1 billion years or so, this increased heat will result in our oceans evaporating, creating a runaway greenhouse effect. Earth will become too hot to support life as we know it, turning it into a barren, inhospitable world. So, while our sun's transformation into a red giant is a concern, the real threat to life on Earth is the slow but steady increase in the sun's luminosity over the next billion years. It's a sobering thought to consider that the very source of life on our planet, the sun, will one day be the reason for its end. It's a stark reminder of our place in the universe, and the finite nature of life as we know it.